So for learning objective 5.9b, I'm going to show you how to set up a falling object model and solve an equation. This here in the blue is called the falling object model, which is considered a quadratic because the highest exponent is a squared. And let me just tell you what these three different variables mean. So t, v of o, and h sub o. T is going to be time in seconds. V sub o is initial velocity. And what velocity is speed with direction. So, for example, if something is thrown upward, that would be a positive direction, and I want to know how fast it was thrown upward. If it's thrown downward, it would be a negative direction. And then the last variable here to define is h sub o, which is our initial height. So what we're going to do, for example, is we're going to throw a ball. And what they might do is say, okay, what if we are at a height of 4 feet, I'm standing here, I'm a person standing, and I throw a ball. So I'm at 4 feet is my initial height, so we're going to identify that, and I throw it upward, so that'd be a positive velocity at a speed of 3 miles an hour. Okay, so that's my velocity. The question might be, how long, so time, will it take for that ball to hit the ground? So in real life, when you throw things upward and that ball travels in the air, it actually moves in a parabolic shape like this. So what we can use is this handy formula called the falling object model or the throwing object model, and it will tell us how long it takes for something to hit the ground. So let me show you an example. Okay, so we're playing volleyball and we hit the ball with an initial velocity of 30 feet per second. So I'm going to highlight that and I'm going to write down velocity. By the way, it's negative 30 feet per second. So we're going to hit the ball downward. So imagine we're playing volleyball. It sounds like we're going to spike it down. And it's when the ball is, let's see here, 8 feet above the ground. So that's our initial height. So that is h sub o. It's 8 feet above the ground. The volleyball lands on the ground after you hit it. Okay, number 66 wants us to write an equation, gives the height in feet of the volleyball above the ground as a function of time. That just means use the formula we just looked at, which is h of t equals negative 16t squared plus vt plus h. So all you have to do for number 66 is plug in the information. So h of t is just function notation. Negative 16t squared stays there. All I need to fill in is the velocity and the initial height. So the velocity here again was negative 30. So do negative 30 t. And initial height is 8 feet above the ground, so I'm going to do plus 8. So this is called a throwing object or falling object model. Now for number 67, they come in and say, find how many seconds is the volleyball in the air before it lands on the ground. And let's imagine this scenario real quick. I want you to imagine here we have the volleyball net and here's the volleyball. A person comes on in and they're saying that this person is going to hit the ball so it travels downward. So what's going to happen is this thing's going to go down like that. And it travels, it looks like this is a 1/2 of a parabola. And then it's going to hit the ground right here. So their question is, how long is it going to be in the air, but when it hits the ground? This ending height here is going to be 0 feet when it hits the ground. So when it hits the ground, goes right here, is our ending height. So if I go into here, number 67, the ending height is 0. If we set this equation up, what we need to do now is what we've been doing, is solve this quadratic equation. We can either factor it, or we could try using the quadratic formula. Now, once we have this equation set up, we can either try to factor it and solve it, or you have to use quadratic formula. And on this one, I think we're going to have to use the quadratic formula, so let's just get that set up. I'm going to identify A is negative 16, B is negative 30, and C is 8, and just set it up and simplify. So here we go. Let's do the setup. So x equals a negative b would be a positive 30 plus or minus the square root of b squared, so negative 30 squared, minus 4, a is negative 16, and c is 8. And this is going to be all over 2 times a. Okay. This will simplify to give us a simplified version, and just follow with me on this. Negative 30 squared is negative 30, which is 900. Then here I'm going to do a negative 4 times a negative 16 times a negative 8. So those three together will become positive 512. So simplifying further, we're going to have x equals 30 plus or minus, it's going to be the square root of 1,412 is going to be 900 plus 512 all over negative 32. Now let's take the square root of 1,412, and that's going to simplify our thing down to equaling 30 plus or minus. It's about 37.6 all divided by negative 3. Okay. Now I'm going to break this off into the two separate answers. Okay, one of them is going to be 30 plus 37.6 divided by negative 3. The other is going to be 30 minus 37.6. Take that whole thing and divide it by negative 3. When you simplify this top answer, it's going to be 67.6 divided by negative 3, which will get us a negative 22.5 seconds, which is backwards in time, so that's not going to make sense. So let's look at the next one here. Here we're going to take 30 minus the 37.6, which is going to give us negative 7.6. Divide that by a negative 3, and we're going to get a positive 2.53 seconds. So this problem takes some work, but the answer is it's going to take 2.53 seconds for that volleyball here to hit the ground.